one of the skills that you're going to need is to go backwards from the process we just did, to start with a graph and come up with an equation that describes that graph. And this is a little bit tricky because there are actually multiple answers for how you do this, and it all depends on how you want to set things up from the beginning. So we'll talk through a couple different ways of looking at this and see how this relates back to what we saw previously. So to determine an equation of this graph. All right, so what can we do? Well, the first thing we want to think about is to figure out where the midline is. Remember that was the first thing we saw from before. And if we look at this graph right here, you see the midline cuts right through there. So this is the line y equals -1. All right, so that's the first thing. Next thing we can see is the upper limit and lower limit, which gives us a sense of the amplitude. In this case, because it's going up and down by 2, we know that the amplitude is going to be 1. Or excuse me, the amplitude is going to be 2. The other thing we need to do is to think about what is the period. Now remember, the period is a measurement from where how long it takes for it to repeat. So we need to find some landmarks, so either the top or the bottom tend to work best, but sometimes you look at the midpoint as long as you're crossing either in the up direction or the down direction both times. In this case, I'll start from here and here, going from the bottom here to the bottom here. How far apart are those things? Well, here's where we have to look at the graph. So we have pi, so it's cut into 3 parts. So each one of these is pi over 3. So 1, 2, 3, 4 pi over 3. So the period is 4 pi over 3. And the last thing we want to do is we want to think about where do we want to think about the graph as starting. And here's where there are multiple options. In this case, I'm going to start from here. I'm going to say that this is the start point, which means that the end point is going to be the next time it crosses up this way. And we'll look at a couple different options that we could have had in a moment. But let's say that's the start and that's the end. What is the shape of the function from here to there? Notice that it looks like a sine curve because it starts at the mid and it goes up and then down and back up to the mid again. If we had picked this point right here, we would have to identify this as a negative cosine because it's starting at the bottom, going to the top and going to the bottom, which is a cosine, but it's flipped over. If we'd started here, it would be a negative cosine because it's starting in the mid and it's going down. So you're just going to have to pick one of those and just go with it. So in this case, as I said, we're starting here. So this is going to be y equals something something involving a sine. And we have to figure out all the bits and pieces that go into this thing. And fortunately for us, we actually have most of the information already worked out. We have that the midline was at -1, so it turns into a -1. We know the amplitude is 2, and it's a sine function, but because it's going up, it doesn't need to have a negative. It's not being flipped over. Now, what about the stuff on the inside here? We're going to have a b value, and then we're going to have a t minus c. The t minus the c, this c right here, corresponds to that starting point. And since these are intervals of pi over 3, 1, 2, this is 2 pi over 3. That part's not so bad. And then we have to figure out what is the multiplicative factor b here. And the relationship that we have is that the period is equal to, period is 2 pi over b. And so if we actually solve for b, b is equal to 2 pi over the period. And since we identified the period here to be 4 pi over 3, we can just plug that in. 2 pi over 4 pi over 3, multiplied by the reciprocal, so that becomes 3 over 4 pi. The pi's cancel out. Let me write that out, even though it's getting cramped down here. So 2 pi, the pi's cancel out. The 2 reduces to a 1/2, so 3/2. So this is going to be a 3/2 right there. Right. And so this equation gives us a possibility for what this graph. Now, the other options that we could have had, if we had started here, what would be different? Well, if we'd started here, I'm going to squeeze this in, even though it's not best practices. I'm going to squeeze it in. So if we started here, notice that it's going to be a cosine graph instead, and starting from the bottom instead of the top. So it would be a negative cosine. The amplitude is still 2. This b value is the same thing because the period hasn't changed. What has changed right here is that now the starting point is this one, which is going to be pi over 3, and then the midline's the same. So here's another value, another equation that you could have gotten. And there are in fact infinitely many possibilities here, and these are just 2 of them. The key ideas we want to keep track of here are, of course, knowing the amplitude and the midline, because that takes care of these 2 values. knowing the shape, so that takes care of whether we have a sine or a cosine and a plus or minus sign here. Making sure that you're consistent with how you start. So once you labeled your start point, that start point is how you think about the shape of the graph, and that start point goes here. And then figuring out the value of b from the period, which goes here.